Hello students, welcome to today's session of Daily Chemistry Dose. So what is stored in today's dose? A question from S block elements. So here comes the question in front of you. Just read the question and my suggestion would be you to pause the video and try to solve it and then see into the discussion. Here comes the question. So as per the question, lithium, it suggests that the lithium reacts gently with water whereas potassium violently. So the examiner is asking that what could be the reason for that. So there are 5 points being given here to you, and out of these 5 points you have to figure it out that which would be the correct reasons for this exceptional behavior, why potassium is reacting very aggressively with water that it even catches fire. So for such questions, what is the beauty of inorganic chemistry? At times I feel that way, that in the question itself the answer is being provided to you. One fact he is telling us, in the question there is an answer that lithium reacts gently whereas water react whereas potassium react violently. Now for to do this question I would suggest you to have your facts and figures clear, because because he is talking about something about melting point of lithium, then delta G of this reaction, then also about the density of potassium. So these are the things which you have to see into your religiously into NCRT. So I would suggest that for inorganic, whosoever is preparing for competition, NCRT could be treated as a sort of Bible, because it is it is containing lot of information, and I would suggest that all the tables which are there in S block, P block, D block of NCRT have to be religiously seen. So if your respective teacher has happened to show you that insight into that table, then only a child would appreciate the facts and figures. So let me write few things first: lithium, sodium, potassium, rubidium, cesium. So if I talk of their melting points, if I talk of melting points, it is 181, this is 98, this is 63, and this is 39 and 50, this much degree centigrade. And if I talk of density, actually you have not to religiously see into each and every aspect, but you need to remember the trend a bit. Say for example, if I tell you about the densities, so first three elements of this S block, lithium, sodium, potassium, have density less than 1 gram per cc. So basically this is the density of water we treat, and these three elements have the density lesser than that of water. This way you should remember it, that they obviously would float on water if put into water, because they are less denser. And also you have to figure it out here that it is 0.54, it is 0.97, it is 0.86, and then 1.53 and 1.9. So here you could also see that potassium is having a lesser density, which is a bit exceptional, that down the group density has to increase. So in one question while discussing this, I am letting you know I am actually preparing 4 5 more questions during the discussion. So I would feel that you would enjoy that thing. So if I talk of their oxidation potential, if I talk of oxidation potential, standard oxidation potential, for lithium we say it is 3.05. I'm not writing it SRP, then it would be negative. I'm writing it in terms of oxidation potential, so it is 2.71, it is 2.93, and 2.92 and 2.92 volt. So what also you would see here is that sodium has exceptionally a bit lesser oxidation potential, because down the group oxidation potential tend to increase, and lithium has unexpectedly very high oxidation potential. This also is a point of concern. So in a question you should know this point. And if I talk of alkaline earth metal, that is beryllium, magnesium, calcium, strontium, barium, all of these have densities greater than 1 gram per centimeter cube. So all of these would not float on water, unlike these three elements which would be floating on water. Here also you would see that down the group, if you could see that the for potassium the density has a bit decreased, you would also see a exceptional trend in case of the calcium. So figure it out and see into the NCRT. Now why I have placed these things, now first we have to see into it what are the facts and figures which are correct and incorrect. So he is saying the melting point of lithium is more than that of potassium. This is perfectly right. We said lithium has a melting point of 181 and that of potassium is 63. So this fact is clear. But now the point is it the reason for the more reactivity? Second is the delta G of the potassium. This we come on to it in a minute's time, and then we'll see density of potassium is lesser than that of lithium. The density of potassium is lesser than that of lithium. So density of lithium is lesser. So this in a way is a wrong statement. So since it is a wrong statement, then you have to see into the options available. So in A and B option, considering all other points, I know this fact is wrong. So if this fact is wrong, so A and B would not be the answers. Now the option left with me is C and D. And you might have seen those who are doing these questions or MCQ questions, whenever you have a option which is a stand alone option, he categorically is writing only point 2 is the correct one, that delta G for potassium is more negative than that of lithium. That does it, what does it mean? That potassium when put into water would generate more heat, and that is why it is reacting fast. So knowingly unknowingly people tend to opt for this option. So I have seen that many of the times that question becomes very tough, in which ABCD is containing lot many options, and one option is a stand alone type of a option, like say in case you have a option given 0 or infinity among the all. So generally that would also be a sort of a uh, important option to select on. So now the point is, in this particular case, that is this second the right statement or not, we have to see into it. So now let me see into it in the terms of E naught values. So what we said in this particular case, that alkali metals react with water to form hydroxide and hydrogen, and delta G is negative and heat is going to be produced. So if this had been a case of lithium and another case of potassium, so for this, if I am able to do sort of, if I am able to find out the delta G, a tentative value of it, then our question, we are through the question. So what we can write it here is that lithium happens to go to lithium positive and electron. For this we have said that E naught is plus 3.05, and what is happening here is water is undergoing reduction. So water when undergoes reduction by this particular reaction, 2OH negative plus H2, for this the E naught is minus 0.83, minus 0.83 volts. So we can do this calculation like this. For lithium I can place it like this, that E naught cell is, you can say it as SOP of cathode minus SOP of anode. If I'm writing in oxidation potential, SOP of anode minus SOP of cathode. So what is anode? 3.05. And what is cathode? You have to write its oxidation potential. So oxidation potential would become plus 0.83. So this is greater than 0. So similarly for potassium, if I write E naught would be 2.93 minus 0.83. So this also is greater than 0. So this is giving us a tentative idea that what would be the, in standard conditions, what would be the E naught values. And for that you also could find the delta G naught. So here if E cell is positive, so delta G would be negative for sure. So delta G is coming out to be negative. And which is more negative? It is because the E cell is more, E cell is for lithium is greater as compared to that of potassium. So delta G, the energy released in case of lithium, is more. So it is quite obvious now that this second statement, the delta G of potassium is more negative than lithium, is a wrong statement. This is being written wrongly. So this is wrong. So what would be the answer? The answer simply lies in the fact that lithium when put into water produces more heat, whereas potassium releases lesser heat. But the lesser heat produced by potassium is such that it allow it to get melted. So potassium melts, and when it melts, its more surface areas is exposed to the water. As a consequence of that, it reacts vigorously. So in this particular question, thermodynamics is not the role which is being playing, it is the kinetics of this reaction which is playing the role. So what should be then the correct answer? The correct answer is happening to be melting point of potassium is melting point of potassium is lesser than that of lithium is the right statement, and it is the kinetics of the reaction, and more surface area of potassium is exposed to the water because it got melted. So this statement is wrong, and this is the right statement. So make it a point. This is a very beautiful question where many of the times when people start seeing some reactions for which the delta G is negative, people tend to feel it that it would react fast. No, delta G only would tell us that the reaction is spontaneous and it would produce more heat if it is negative, but it is not telling about anything about the kinetics of the reaction. So I hope you enjoyed today's session. Hope to see you once again. And in case you have not yet subscribed to my channel, do subscribe it so that you could get the latest notification as and when new video is made by me. Hope you have enjoyed today's session. Have a nice day. Take care and stay safe.